Hello friends, this is Karthik Bharadwaj. Now we are going through the part 4 ISRO 2015 question paper, in which we are going to discuss about question number 61 to 80. And for the previous lectures, I have already discussed from question number 1 to 60. If you want to know the detailed solution of these questions, you can watch all these lectures, ISRO 2015 part 1, part 2, part 3. Please go visit my channel Karthik Bharadwaj, and in the playlist I already discussed all these questions. So here I begin with question number 61. I already told you that over the official page, the question paper provided by the ISRO missed out some pages, some questions which I have already included in my lectures. So let us start from question number 61. Now in the question number 61, we are giving that equivalent circuit of FET, in which Rg is the 100 ohms, CGS is 0.1 picofarad, and Gm is 0.1 mho, and load resistance is 500 ohm. Now we have to calculate the voltage gain at 1 gigahertz. Actually this is the operating frequency, and we have to calculate voltage gain. Now we know that voltage gain is equal to Gm into RL. So this is the value of the voltage gain. By putting Gm into RL, we can easily get the value of the voltage gain. Now this is the simple solution. Gm into RL, 0.1 into 500, that will be equal to 50, and the option will be A. So this is the option will be in this question. Now going through the question number 62, in which it is given that NMOS transistor is operating in linear region, and we have to find out that. So friends, yeah, this is actually basically simply a concept. If you are going through the equations of MOSFET or NMOS or PMOS, then you can easily detect all these things. Here VDS is less than VGS minus VT. If it is operating in that region, then it is under the linear region, and if DS is greater than VGS minus VT, then it is under the saturation region. So remember it, friend, and there is no logic of all these two things. So this is under the linear region and this is under the saturation region, and the question is asking about the linear region, so option A is the right answer. Now we are moving through the question number 63. In the question number 63, we have given that input impedance is equal to lambda by 4, lossless and 50 ohm transmission line transmitted with 25 ohm. So we have already given all these things. We have simply put it into the formula and we get the answer. So we have L is equal to lambda by 4, BL is equal to pi by 4, and Z0 is equal to 50 ohm, ZL is equal to 25. By simply putting in formula, Zin is equal to Z0 ZL plus JZ0 tan beta L over Z0 plus JZL tan beta L. By putting all these things, these data in these questions, we can easily get option C, that is 50 ohm. Okay, so you will easily get this answer. Now we have given that microprocessor is pipelining technique is used in microprocessor to improve which of the following parameters. So actually this is used, pipelining is used to maximize the throughput. Actually number of operations completed in number of operations completely executed, that is called throughput. So we just want to improve the throughput efficiency. So that is why we are using pipelining technique, in which maximum clock frequency we have to improve. So that is answer D. D will be the correct answer. Now we have given that ideal class F micro amplifier, and we time domain voltage and current waveform of the device have कितने % overlapping है, how much overlapping is there. Actually the time domain voltage waveform जो होती है, that is equal to the square wave, that will be equal to the square wave, and the current waveform is the half sine wave. So if we are talking about the overlapping, there is no correlation, so there is no overlapping. So the answer will be C. There is no overlapping. Now in question number 66, there is given that for superior high frequency performance of the metal semiconductor diode compared to the PN junction diode is. Actually this is the basically the advantage and disadvantage regarding to the metal PN junction or metal semiconductors. So here actually metal semiconductor having a metallic contacts, so there is no minority carrier, there is majority carrier, so there is less reverse saturation time. So this reverse recovery time, this is reverse recovery time. Actually this helps in the switching. This is the combination of the electron hole pair, that is called reverse recovery time. So actually there is majority carrier in metal semiconductor in which the reverse recovery time is reduced. That's why it is used for the switching. At high frequency it is used as a switch. So the B will be the correct answer which is available here. Now the question number 67 also related to the previous point. Which of the following diode is most suitable for the detection of the microwave signal? We know that the microwave signals having very high frequency, so normal PN junction is and varactor diode, all these things are not working here. So Schottky diode, barrier diode is best option available here, as you know that reverse recovery time is less, so it can be act as a switch, है ना? So it is very suitable for the high frequencies. Now in question number 68 we have to discuss about which device is suitable for the RF frequency multiplier. So the correct answer is option D, step recovery diode. Now we are moving through the question number 69, in which we have given that we have to be calculated S11 scattering parameter 11 S11 we have to be calculated, and we are giving a network having a resistance of 15 ohm. Now first of all we should have to make a Z parameter, एक Z matrix बना लेते हैं. Now Z matrix is equal to 50 50 50. So everything Z11 Z12 Z21 Z22 everyone is 50. Now we can normalize that by taking dividing it by 50, so that will be 111. And now S parameter can be calculated Z minus U, that is unity matrix, Z minus U multiply by Z minus U inverse, and by calculating Z is 111 minus unity matrix इसमें करेंगे, then we will be able to 0 1 1 0 unit matrix. We are subtracting Z, that this is Z, and we are subtracting Z minus 1 0 0 1, that is unit matrix. So after getting that, after doing that subtraction, we are getting that matrix, and now we have to be calculate Z minus U. So that will be this will be Z minus U inverse. We have to find Z plus U हो जाएगा friend. This is not Z minus U, this is Z plus U inverse. We have to calculate inverse. No, that will be 2 1 1 2, and if we are taking an inverse in second 2 by 2 matrix, then simply we can do it by exchange these values and by multiplying minus 1 in that values, so we can easily obtain the reverse, and definitely determinant divided by the determinant. So determinant of this matrix is 1 by 3, and by taking the inverse of this, so we have to simply exchange these values A11 and A22. We should simply have to exchange this value, and by multiplying A12 and A21 by minus 1, so we can get that matrix. So after multiplying these matrix, we can easily calculate that S1 is 1 minus 1 by 3, and minus that is 180. So C will be the correct option which is available here, है ना? So this is 1 by 3 180, है ना? Now we are moving to the question number 17. Actually we have given the question number 17, in which we have given that VI characteristics of the Schottky diode we have given. 2 RF power levels पे हमें दिया हुआ है Schottky diode का, and now we have to be know about the RF resistance of the diode. Actually look at here at this point, what will be the value of V and what will be the value of I. Now if we are increasing the value of V, the value of the I is increasing, decreasing. Okay, you can simply know that for that value of I, then that for that particular point the value of V is V1 and this one is I1, and at that point we have value of V2, and this one the corresponding value यहाँ पर, that corresponding value is I2. So this is less in comparison to previous value. The current is decreasing. So current is decreasing, simply the resistance is increasing. So C will be the answer. Resistance will be increasing with increase the RF power level. So from that particular graph the answer will be the C. Now question number 71, we have to be calculate, we have given that emitter, we have common emitter BJT, in which we have given current gain is beta is equal to 100 is given, and 10 volt supply is providing, VCC is given 10 volt and VB is 0.7, and we have to calculate RC and RB. Simply we should have to apply KVL in that loop and in that loop. So I have already discussed all these things here. In the first loop, while I am applying this KVL in the loop 1, so minus VCC, ICRC, and this is that is values VB VCE. So plus VCE is equal to 0 by putting all these values, because VCC is given 10 volt, VC is given at 8, and IC is given 10 milliampere. So we can easily calculate that will be 100 200 ohms. Now applying KVL in that loop 2, and actually we have given that here we have given that IC, we have given IC 10 milliampere, we have given IC, and we have to be calculate here IB. So beta is equal to IC over IB, so IB can be easily calculated IC over beta, so that will be 10 to minus 4 ohm. By applying this, by applying KVL in that loop, 10 minus 10 IB RB VB, है ना, that is VB. So this will be 10 minus 0.7 divided by 10 to the power minus 4 IB. Already we have calculated here. Now putting all this value, we can easily get the answer 93 kilo ohm. So the answer RC is 200 ohm and RB is equal to 93 kilo ohm. So the answer is matched with the option number A. The option A is the best answer, which already given here. So in the question number 72, we have to find out which statement is false about the microstrip lines over the strips line. So this is the first point. Absolutely, if you have little bit knowledge regarding the microstrip line, then it is less radiative. No, that is why microstrip antenna are used in our mobile and cell phones, etc. So the option number A, the less radiative, will be the appropriate answer, which is already given in here. In question number 75, we have given that a MOS 73. Sorry, in question number 73, we have given MOS FET is given. So high gain is already given. Case 2 channel resistance, the theta case 2 channel resistance is given 4.5 degrees Celsius per watt, or RF value, that is power is P. P out is 8 volt. P in is 20 watt. Sorry, not watt, and P in is 20 watt, and the channel temperature is given at case tab is 55 degrees Celsius. So now P out is 8, P is 20, T case is 55 degrees, P channel we have to find out, and case 2 channel is given that. So case 2 channel is equal to T channel minus T case divided by P in over P out, by putting required value from the given data in that equation. बस हमें basically ये equation पता होनी चाहिए थी. If we already know this equation, we can easily put all these values from the given data to that equation and easily calculate the answer. That will be 109 degrees Celsius, 109 degrees Celsius. So that is the option A. Now we have given that a class A FET power with 10 volt drain supply, 2 ampere drain current, RF load current is 1 ampere amplitude. What is the DC to RF efficiency for the load resistance of 5 ohm? So friends, we have given data and we have to calculate efficiency. Efficiency is equal to VC multiplied by ICE divided by VCC into ICQ. Now VCC को by putting this value, VCC is equal to ICC into RL, then ICE square over RL VCC into ICQ. By putting all this value in the given form, actually we have given the IC is equal to 1 ampere, because we have to be taken RMS value, that is 1 by under root 2. So that is why we are taking 1 upon under root 2, that is the RMS value we have given here. So considering here, so by taking the square of that value multiply by R 5 and divided by 10 into 2, that will be 12.5%. This is the appropriate answer, which is matching with our option number D in the given options. Now we are moving through the DC to RF efficiency of class F amplifier. So that is 100%. So A will be the correct option in that. Now we are moving through the unilateral transistor had output impedance. We have given that output impedance 10 minus 10 J, and value of the series and shunt component matching network. We have to calculate these values x1 and x2, and we have given that load resistance is equal to 50 ohm. So actually this is Z out is parallel, this Z out is parallel with well, if we are considering here, then the input what is the resistance here will be the parallel in Z it is series with Z out is series with x2 and parallel with x1, so that will be equal to the load resistance. So this is the complex value. This we can take the conjugate, but there is no need to take conjugate here. Well, by putting these values, we can easily find that by putting Z value, that is 10 minus J 10 omega plus x2, which actually we have to find parallel with x1. So we have to be substitute these value one by one, and from by putting these value we will find that option number A will be the appropriate answer. That will be the way to solve this question. So that answer A is correct here. Now in question number 77, actually we have to discuss question number 77. We have given that bandwidth is equal to 3000 Hz. Transmitting power we have already given the transmitting power says that, okay, we have given signal to noise ratio, that is 1023. Maximum data rate we have to find out, error free through the channel. Okay, we know that this is the Shannon-Hartley equation, in which this is the capacity of the channel is equal to bandwidth log base 2 1 plus SNR. So channel capacity of this channel is bandwidth is 3000 log base 2 1 plus 10, or so. If we solve this question, then we will get 30 kbps. By solving this data, we can easily get 30 kbps because you know that how to solve it. Well, so we know that for the lossless error-free transmission, channel capacity will be more than the data rate. So maximum data rate of the free transmission is 30 kbps. So that will be the answer, which is matched with option B. Okay. Now question number 78, in which we have to find E by B, EB by I naught is equal to 10B. We can easily convert it into the simple form, that will be also equal to the 10, and we have to calculate, we have given data rate is 1 kbps and chip rate is over 1 Mbps. So EB by I naught will equal to the omega, this is chip rate to y rate, data rate, and minus 1. By putting all these value here, we can easily calculate n is equal to 101. This is equivalent to 100, which all these options available here, 100 is best suited here. Now in the question number 79, you all know that what is the Laplace transform of sin omega t, that will be omega over sin s square plus omega square. So we have given already given that e raised to power theta t. So if we convert it into the s domain, frequency domain, that is s minus theta. So B will be the appropriate option from the given above problems. They are very basic question. Now in question number 80, we have given that circuit in which two capacitors are added, and we have to find out the energy stored under the steady state. Actually, we know that DC current is there, and in DC steady state, when DC supply is provided in steady state, capacitor act as an open circuit. So these are the open circuit. If we remove all these two from these circuits, we can shift, we can switch these capacitor with open circuit. Then we have to calculate energy in that form. So AD, we have to calculate simply, and BC. We have to calculate by simply using the voltage divider rule. So we have to be AD, we have to calculate AD. That will be equal to 2 plus 4, 6 by 8, because total resistance is 8 ohm and 6. So 6 by 8 into 10 raised to into 16. So that will be equal to 8 16. That will be equal to 8. 12. Sorry. 8 दूनी 16 6 दूनी 12. Okay. Then that will be equal to 12, and this will be equal to BC. So up we have to be calculator. We know that energy is equal to half CV square. That is the energy stored in the capacitor. So because capacitance of the both capacitor is say that is equal to the 2 microfarad, and we have given that voltage also same, that is 12 volt. So by putting on this value simply in that equation, we easily get 2.88 into 10 raised to power minus 4. So this match with option number C, which is best available here. So in this way finally we conclude all the questions here, and we finished off our question number paper ISRO 2015, in which we have discussed already all the questions in the ISRO previous in the ISRO asked in the ISRO. Well, I have to be say that friends, if you have find any mistake in my detailed explanation, actually I am not perfect. I try to find out all this solution by using the different resources available in the market and Google and asking some of my intelligent friends. So if you have find any mistake in my lectures, then simply write it down under the comment section. The motive of my video lectures is that I can provide you the solution, so that you can easily get all these resources at one place and get some idea regarding to the exams and exam pattern. So if you like my channel, you like my descriptions, or you find that my video is helping you out, please like it, share it, comment it, and if you are watching my video first time, please subscribe my channel, that is Karthik Bharadwaj. So ISRO is very ahead to us, so wish you all the best from my side, all the best. May God bless you, or all the wishes. Thank you so much. Have a nice day. Bye. Take care.